that can transmit data signals from a source to destination can qualify as a physical medium. Keeping this in mind, physical mediums can be classified into two types. Guided physical media includes twisted pair cable, coaxial cable, and fiber optics. Unguided physical media includes radio wave frequencies, microwave frequencies, and infrared light. Twisted pair is composed of two insulated copper wires that are twisted around each other to minimize interference and noise from other wires. According to the types of shielding used, there are two classifications: unshielded twisted pair or UTP. A UTP cable is a 4-pair wire. Each of the 8 individual copper wires in a UTP cable is covered by an insulating material. In addition, the wires in each pair are twisted around each other. The UTP cable is able to cancel all sorts of electromagnetic interference or EMI and radio frequency interference or RMI. This is possible due to the fact that the twisted pairs limit signal degradation. The number of pairs in UTP generally varies to reduce further crosstalk or signal interference. Shielded twisted pair or STP. An STP is constructed in a manner similar to the UTP cable. However, shielded twisted pair cables are further protected against signal degradation by wrapping each pair of braided wires in a metallic foil. The 4 pair of wires are then wrapped in an overall metallic braid or foil, which usually consists of a 150 ohm cable. STP is generally specified for use in Ethernet networks installations and is capable of reducing electrical noise both within the cable and from outside the cable. Coaxial cable is also known as coax. It is basically an electrical cable with an inner inductor and an outer conducting tubular shield. These are separated by a flexible tubular insulating layer. At any moment, the current is traveling outwards from the source in one of the conductors and returning in the other. However, since it is an alternating current, the current reverses directions many times a second. Coaxial cables are designed to carry radio frequencies having currents of a frequency much higher than the 50 or 60 Hz used in the main power cables. So it reverses directions millions to billions of times per second. Ideally, the electromagnetic field carrying the signal exists only in the space between the inner and outer conductors, thus allowing the cables to be installed next to metallic objects, without the fear of power losses inherent in other types of transmission lines. An optical fiber is a glass or plastic fiber that carries information as light along its length. This allows us to achieve high bandwidth data transfer using narrow beams of light carrying electromagnetic signals. The core of a conventional optical fiber is a cylinder of glass or plastic that runs along the fiber's length. The core is surrounded by a cladding of different glass or plastic having a lower refractive index. Light traveling in the core reflects from the core cladding boundary due to the total internal reflection, as long as the angle between light and the boundary is less than the critical angle. As a result, the fibers transmit all rays that enter the fiber with a sufficiently small angle to the fiber's axis. Fiber optics are classified into two types on the basis of modes. Multimode fibers support more than one mode of propagation. Single mode or monomode fibers support only one mode of propagation. Radio wave frequencies refers to the frequencies of radio waves and is a part of the electromagnetic spectrum that ranges from 3 Hz to 300 GHz. These waves are radiated by an antenna and produced by alternating currents fed to the antenna. This medium is used in local wireless loops. Microwave frequency is a part of the upper RF spectrum with frequencies above 1 GHz. Because of the availability of a larger bandwidth in microwave spectrum, microwave is used in applications such as wireless PAN or Bluetooth, wireless LAN or Wi-Fi, and broadband wireless access or wireless MAN, WiMAX, wireless WAN, and satellite communication and radar. Infrared light is a part of the electromagnetic spectrum that is shorter than the radio waves but longer than the visible light. Its frequency range is between 300 GHz to 400 THz. Infrared is also one of the physical media in the original wireless LAN standards, that's IEEE 802.11.